college enrollment. The statistical abstract of the United States reported that 66% of students who graduated from high school in 2012 enrolled in college. 100 high school graduates are sampled. Let X be the number who enrolled in college. Find the probability that at least 75 students enrolled in college. First, observe that X is a binomial random variable because the conditions are there a fixed number of trials? In this case, the answer is yes. N equals 100. 100 students. We check each one. 1, 2, 3, 4, 5, all the way to 100. Are the trials independent? In this case, we would have to assume that yes, they are independent because we assume that this is a random sample. We assume random sample in a probability problem. And we assume that the students are making decisions independently. Are there only two outcomes in each trial? A trial is a student in this case, and yes, because we define X to be the number of students who enrolled in college, the outcomes is that whether they enroll in college or whether they do not enroll in college. So there are two outcomes. Is the probability of success lowercase p equals 0.66 in this case. We were told that the study suggests that 66% of students who graduate from high school enroll in college. So randomly pick any student, the probability that that student enroll in college is 0.66. Therefore, the probability of failure is 1 minus 0.66 or 0.34. This is a binomial random variable with the parameters n equals 100 and p equals 0.66. Now that we have the information for the binomial distribution, specifically we have the parameters n and p, we need to rewrite it in symbolic form. The probability that at least 75 means 75 or more. In this case, the possible values for X are, could be possible that 0 enrolled in college. Yes, it is highly unlikely, but it is possible. Is it possible that only 1 enrolled in college? Yes. 2? Yes, all the way to 100 only, because this is the sample that has only 100 students. And so for the statement at least 75, what numbers in this list would satisfy this statement? And again, at least 75 means 75 and more. And so we would have to write this at X greater than or equal to 75. Binomial distribution is a discrete random variable. It makes a huge difference whether we include the equal sign in this inequality or not. Once we have the parameters along with this symbolic form, we're ready to use a calculator. There are many calculators that can compute this probability. We will use Desmos binomial calculator. But with any calculator, we would need to specify the parameters for the binomial distribution n and p. N is the number of fixed trial, and P is the probability of success. In this particular problem, N is 100 and P is 0.66, 66%. We wrote down the probability in symbolic form, which is X greater than or equal to 75. We're looking for that probability. And the range for X greater than or equal to 75 out of 100 is 75, 76, 77, all the way to 100. And so the minimum value is 75 and the maximum is 100. And there it is. The answer is 0.0340. And so the probability that we're looking for is 0.0340. For part B, similarly, before using the calculator, we would need to write the probability in symbolic form. The probability that more than 75 students enrolled in college, more than 75, remember that there are 100 students total. More than 75 means 76, 77, 78, all the way to 100 in symbolic form. This is P, probability of X strictly greater than 75. Now the values that are strictly greater than 75 are 76, 77, all the way to 100. And so the minimum will be 76 in the range and the maximum in the range is 100. And we're working on the same problem where x is a binomial distribution with the parameter n equals 100 and p equals 0.66. And so we're ready to use the calculator. We will use Desmos binomial calculator. Again, the first thing we will need to do is to specify the parameters. N is 100 and P is 0.66. The minimum in the range is not 75 because this is more than 75. And so 76 is the minimum and the maximum is still 100. The probability that we're looking for is 0.0203 rounded to 4 decimal places. And so this is 0.0203. Lastly, we're looking for the probability that at most 75 students enrolled in college. Now, for this discrete problem, x, the value that x can take on are 0, 1, 2, 74, 75, all the way to 100. At most 75, the value that are at most 75s are 0, 1, all the way to 75. But the maximum is 75. And so in the range, the minimum value that we would use is 0 and the maximum values will be 75. Note that the minimum value is not 1. It is possible that none enrolled in college, so x is 0. In symbolic form, this is P of x less than or equal to 75. This is also the binomial distribution that we are working with n equals 100 and p equals 0.66. And so we are ready to use the calculator. Again, using Desmo.com, binomial calculator, specified n 100 and p 0.66. We have the minimum is 0, not 1, and the maximum is 75. The probability that we're looking for is 0.9797. So the answer is 0.9797, rounded to 4 decimal places.